In this tutorial, we will learn essential basic operations with kubectl. Discovering cluster information is our first step. As we execute the kubectl clusterinfo command, the console reveals essential details about our Kubernetes environment. Moving on, let's explore how to list various Kubernetes resources. Initiating with kubectl get nodes, we observe the lone minikube node, characteristic of our single-node minikube cluster. To delve into namespaces, executing kubectl get namespaces unveils the existing namespaces. Executing kubectl get pods within a specific namespace unveils the diverse pods residing in that segment of the cluster. Likewise, kubectl get deployment within a namespace unveils a list of deployments, while kubectl get service provides insights into services within the same namespace. Likewise, we can list different Kubernetes resources by using kubectl get command. Next, let's learn how to fetch logs. Use kubectl logs to retrieve logs from a pod. Kubectl logs followed by pod name followed by -n and namespace. As we execute the kubectl logs command, a cascade of log information unfolds on the console, offering a valuable resource for troubleshooting purposes. Moving forward, we'll explore the process of deploying an application. Begin by obtaining a straightforward application deployment YAML file from an accessible source, such as Google. Once acquired, create a dedicated directory for your Kubernetes-related files. Paste the deployment YAML into this directory. The provided deployment file is configured to run 3 replicas of the Nginx application pod, specifically version 1.14.2. We will deploy using kubectl apply command. Kubectl apply followed by -f followed by filename. Upon successful execution, a confirmation message will display, indicating the creation of a deployment named Nginx deployment. To confirm this, let's list our Nginx deployment. Executing the command kubectl get pods reveals that 3 replicas of the Nginx application are in a running state, a clear testament to the successful deployment process. Next, let's explore how to execute commands within a pod. Use kubectl exec command to execute commands within pod. Kubectl exec it followed by pod name followed by -n namespace -- command e.g. pwd. Initiating with the pwd command provides the current working directory within the Nginx pod. Now, let's experiment with the env command to retrieve a list of environment variables set within the container. For a more interactive experience, we can connect to a bash session within the pod using the bash command. Once executed, you'll notice a prompt change, indicating that we are now within the container. Within this environment, feel free to run additional commands. When you're done, use the exit command to gracefully exit the pod or terminate the bash session. Moving forward, let's delve into the process of scaling deployments. To scale deployment, use kubectl scale deployment command. Kubectl scale deployment follow deployment name -- replicas equals number of replicas. When we list the deployment, it's evident that all 4 pods are successfully running. Further inspecting the pods, we notice the recent addition of a new replica, created just 17 seconds ago. Continuing our exploration, let's understand how to update a deployment. To update deployment, use kubectl edit command followed by deployment name and namespace. As an example, we will see how to update the image version of a deployment. Search for image and we will change the image version to latest. Save and close the changes, and upon a successful update of the deployment, you'll receive a confirmation message indicating the editing of the deployment. Subsequently, as you observe, all pods are showing age of 7 to 8 seconds, reflecting the uptake of the new image version. Next, let's understand how to expose service. To expose a deployment as a service, use kubectl expose deployment command. Kubectl expose deployment followed by deployment name followed by -- type equals node port -- port equals port number. This command creates a new service with a node port type, making it accessible externally. Verify that the service has been created and note the node port assigned to it. Next, let's understand how to access the service. To access a service from outside the cluster, we will use kubectl port forward command. Kubectl port forward followed by service/service name followed by local port :service port. This command will forward traffic from your local machine to the service. In this example, we are forwarding local port 9090 to the service's port 80. Open your web browser and navigate to http://localhost 9090. You should see the default Nginx welcome page. The requests are being forwarded from your local machine to the Kubernetes service running in the cluster. Press Ctrl+C to terminate the port forward command. Continuing our journey, let's explore the process of deleting resources. To delete any resource, use kubectl delete command. For example, to delete service, use kubectl delete service followed by service name -and namespace. No need to specify namespace if resource exists in default namespace. Similarly, proceed to delete the deployment. Upon listing pods afterward, you'll observe an empty list, confirming the successful deletion of the deployment. Here is the summary of basic operations using kubectl covered in this tutorial. Thanks for watching. Subscribe for more content.